Okay, good morning, friends. Let us discuss the model 3, that is a serial communication, the different types of serial communication, and the different modes, and how to program the serial communication. What are the advantages of the serial communication? Let us discuss for the 8051 microcontrollers, third model called as a serial communication. Okay, I want to share the screen. Go to the material already have sent in the Google class. So, what is serial communication? The bits are sent serially one by one. Then it is called as a serial communication. The communication takes place between the two devices, two peripheral devices. Okay, there are two types of communication. The data you can send parallel or serial. If the parallel means a byte is sent, a byte, the whole 8 bit is sent at a time, then it is called as a
criteria 7 file criteria 7 file numerical
ಯಾವುದು
criteria 7
ಯಾರು ಕೇಳಿದ್ರು
ಗೀತಾಂಜಿ
ಫೈಲ್ ನಂಬಲ್ಲಿ
ಕೊಡೋದು
Okay, let us discuss about the serial communication. So let us see the basics. The computer transfers the data in two ways. As I told, it is a parallel communication. Here you can observe the parallel communication. So this is the parallel communication. So here you can see we have the data D0 to D7. This is the one device. This is the another device. This is called the sender, and this is the receiver. Okay. So sender to receiver, we have the data starting from D0 to D7. Okay. And this type of communication, the connection of the D0 to D7 to the from sender to receiver. Okay. And the sending of the data is called as a parallel transfer. Here you can observe in this figure, in the parallel transfer, D0 to D7 sent at a time. means a byte. A byte is sent at a time. Okay, after 8 or more lines. Okay, so these are all wire lines, conductors. These are connected to transfer a byte. Okay, so bits are sent D0 to D7. The whole byte, this is called as a byte, is sent from sender to receiver. And second type of communication which is used to transfer the data called as serial communication. This is a widely used communication method compared to the parallel. Parallel communication are suitable to send the data for the short distance. Okay, here you can see few feet away. If the devices, the sender and receiver present within the short feet away, short distance, then the parallel transfers are suitable. It means that the parallel transfer is not suitable for the long distance. For long distance communication, the parallel transfer is not suitable. One of the example of the parallel transfer is a connection of a computer to a printer. Okay, printer connected to a computer is an example of a parallel transfer. Okay, so second type, which is widely used for the long distance. For a long distance communication, a computer is connected with the another computer. Both are far away, and we want the data communication between these two computers or systems. Then we have to go for the widely used communication called as a serial communication. To transfer, what is serial communication? To transfer a device located many meters away, as I told, for the long distance. Okay, the serial method is used. The data is sent one bit at a time. Okay, one bit at a time. Means the data are sent D0 first, then D1, D2, D3, D4, D5, D6, and D7. So like this, the data are sent from the sender to receiver. So serially, the data are sent and at a time one bit. Here you can observe the difference. 8 bits sent at a time in a parallel, whereas in serial, 1 bit sent at a time. Okay, parallel communications are suitable for short distance and the serial communication is suitable for long distance. Okay, so at the transmitting end, the bytes must be converted into serial bits using parallel in, serial out, shift registers. If the communication is here, any device, okay, but the data processing in any device CPU is in parallel. Remember, all the data are processed within the architecture is in parallel, but we want the data to be sent in serial. So at that time we require the one of the register which is used to convert the data which is present in parallel in the serial out. Parallel in, and that is called as a parallel in and serial out shift register. The use of this shift register is convert the parallel in, input is a parallel. Okay, please remember all the data are processed, bits are processed within the architecture in parallel, and we want to send the data in serial. Okay, the process of the data in parallel and we want the data to be sent as serial. So we have to convert. Okay, we have to convert at the transmitter device. We require this shift register which is used to convert the parallel data into the serial data. Okay, so that is done by shift register. The name of the register is called the shift register. The same opposite operation had to be performed at the receiver end. Okay, where we are getting the data in serial, we are getting the data in serial, that is serial in. Okay, as I told, the CPU and internal architecture process the data in parallel. So now that we have to convert the serial in and parallel out. So here you can see at the receiving end, this is the transmitting end, this is the receiving end. There is a serial in and parallel out shift register. Okay, again here we have the shift register. We are receiving the data at the receiving end as a serial. Are getting between the transmitter and receiver, the data is sent in serial, and processing of data bits processed in a parallel. Okay, so at the receiving end, we have the data received in a serial, and we have to convert into parallel. So parallel out, that is called as serial in and parallel out, and that is done by using the register called as shift register. Okay, when the distance is short, the digital signal can be transferred as it is on a simple wire or require no modulation. The distance is short between the two peripherals, then there is no need of modulation. The meaning is there is no need of modulation. The data are sent directly through the pair, through the wire. Okay, through the wires, directly we can send the data from the transmitter to receiver. And there is no requirement of the modulation. But the modulation is required when the data is to be sent for the long distance. Okay, modulation technique we have to employ if we want to send the data for the long distance. So data is, example is a telephone line, and it must be converted into 0 and 1 to the audio tones. The conversion of the signal converted into the data which is converted into 0 and 1 is performed by a device called as a modem. So modem stands for modulator and demodulator. This conversion is required if the data had to be transferred is long distance. For the long distance, we are sending the data, and the data at that time we require the modulation techniques, and the data is converted into had to be converted into 0 and 1, and this conversion is done by a device called as a modem. Okay, so modem stands for modulator and demodulator. The modem stands for modulator and demodulator. Is it clear? So serial communication, parallel communication, the use of the modem and the requirement of the shift registers. Now let us discuss the serial data communication. There are two methods. There are two methods employed for the serial data communication. To implement the serial data communication, we are using two methods. The first method is called as synchronous, and the second one is called as asynchronous. Synchronous, in the synchronous data communication, it will transfer a block of data. Okay, a block of data, nothing but the character, nothing but it is also called as a character. Synchronous method transfers a block of data. Block of data are characters. Okay, the block of data is also called as a characters. So it will send the characters at a time. Then it is called as a synchronous data communication. Okay, another data communication method is called as asynchronous method. In the asynchronous method, instead of the character block, it will send a byte. Okay, a byte at a time. Okay, so asynchronous and synchronous. Synchronous send a block of characters at a time. Asynchronous method send or transfers a single byte at a time. So these are the two serial data communication methods. So one of the dedicated IC which is present to perform this type of data communication called as a UART and USART. Okay, so here you can see UART stands for Universal Asynchronous Receiver Transmitter. So these are the special ICs. Okay, these are the special ICs to transfer the data synchronous and asynchronous is done by writing the software code. Okay, but it is very complex and tedious process. Okay, to employ the synchronous or asynchronous, we can do by using the softwares, but a software method is very tedious and time consuming and very, what you say, tedious process. So instead of that, a dedicated integrated circuits manufactured by the different companies to employ the serial communication, and that dedicated ICs are called as a UART. Instead of software, we are using the dedicated ICs called as a UART. So UART stands for Universal Asynchronous. A stands for asynchronous receiver and transmitter. This dedicated integrated circuit is used to implement the synchronous data communication. And one more integrated circuit which is widely used compared to the UART is a universal. Yes, stands for synchronous, asynchronous receiver and transmitter. Okay, so UART, universal asynchronous receiver transmitter, USART, universal synchronous and asynchronous receiver and transmitter. So these are the two dedicated ICs manufactured by the companies. Data can be transmitted and received in a duplex transmission. The data transmitted in one way, we can send the data in one way, means from the sender to receiver, that is one way communication. The data may send two way, okay, from the sender to receiver and where receiver to transmitter or sender, then it is called as a two way. Okay, and data can be sent as a half duplex. Okay, so this is the shown here in this figure. Here you can observe simplex, half duplex, and the full duplex. In simplex, you can see here we have the transmitter and the receiver. Here you can see the one-way communication. Data is transmitted in one way. Data transferred in the one direction. There is no opposite direction data transfer, means receiver to transmitter. Then this type of data transfer between the transmitter and receiver is called as a simplex. Okay, this is called as a simplex. So one of the example is the pagers. There we send the information, and one more example is the sending of the SMS. There we are sending the data in a one way. There is no acknowledgement or there is no reverse operation. So this is the one way data transfer is called a simplex. The second one you can see here, half duplex. There we have the transmitter, receiver, transmitter. Transmitter sends the data and receiver at the receiver. Receiver sends the transmitter here, sends the data, and receiver receives here. Okay, so both the operations are performed in a two way, but not at the same time. Okay, the transmitter sends the data from the transmitter to receiver. At that time, this transmitter at the receiver side had to be wait. Okay, there is no simultaneous data transfer here. There is no simultaneous data transfer from the transmitter to receiver and the transmitter to receiver. Okay, this is the sender and this is the receiver. Okay, so in a half duplex, there is a two-way communication. There is a two-way communication, but the communication is not simultaneous. When transmitter sending the data to the receiver, this transmitter have to wait. Okay, then after receiving the data at the receiver, then this transmitter sends the data, and at that time this transmitter have to wait. Okay, so it is a one of the example called as a half duplex. The example is called as a This is the technique is called as a half duplex. Okay, remember there is no simultaneous transmission of the data in a two-way. Okay, then it is called as a half duplex. The example for this type of communication is nothing but the defense people and the police personnel use of the walkie-talkie. Okay, you might have seen the walkie-talkies. The walkie-talkie is an example for this half duplex. Okay, then coming to the full duplex, here you can see the transmitter receiver, and here we have the transmitter receiver. The data transfer in the two-way direction simultaneously. Okay, there is no without any break or without any discontinuity. The data are transferred from the transmitter to receiver at the same time from transmitter to receiver. We require two wires here. Here you can see first wire and this is the second wire. Okay, and the communication take place. There is a communication take place simultaneously. Then it is called as a full duplex. Simplex one way, half duplex two way, but not at the same time. But full duplex, okay, there is a simultaneous transmission from the transmitter to receiver and receiver to transmitter side. Okay, so these are the three methods. Please remember simplex, half duplex, and full duplex. So to perform these and to avoid the corruption of the bits are sent one by one in a serial communication. We are discussing here the serial communication. So in serial communication, we are sending the bits one by one. So many bits are sent from the transmitter side to receiver side. There are chances of corruption or the bits are corrupted, and it will make confusion to the receiver. Okay, when the bit is received, to avoid these, they are using one of the technique is called as a framing. Here you can see the framing. So the framing is nothing but how the bits are arranged. How the bits are arranged, and we have to insert the start bit and the stop bit at the start of the bit and at the end of the bit. Means at the start of the D01, at the start of D0, we have to insert the stop bit, and at the end of the D7, we have to insert the stop bit. Okay, so a byte which makes D0 to D7. So D0, before starting of the D0, we have to insert the start bit, and at the end of the D7, we have to insert a stop bit. So these start, stop at the beginning and at the end of the bits is called as a framing. These are used to avoid the confusion to at the receiver side. The data is packed. How the data is packed? How many bits are constitute a character when the data begins and when it is end. So these are governed by a protocol. We require a protocol. Okay. So this is the protocol. The use of bits, how the bits are packed, and when you have to use the start bit and end bit. Okay, and how many bits constitutes a character. So these are governed by a protocol. We require a protocol. Okay, so this is the performed by the protocol. Asynchronous serial data communication is widely used for the character-oriented transmission. As I already told, asynchronous compared to synchronous, asynchronous type of serial communication is widely used. So we are inserting here the start bit and end bit. The start bit is always 1 bit, but the stop bit can be 1 or 2 bits. The start bit is always 1 bit. Okay, 1 bit we have to insert at the beginning of the start bit, and at the end of the bit means D7, we may have 1 or 2 bits. Okay, so this is called as a framing. Okay, please remember this is called as a framing. These are used to facilitate and increase the efficiency of the data by using some protocol. Here you can see the example, start and stop bits. The start bit is always 0, means a low signal, and the stop bit is 1 or it is a logic high. Start bit is of 0 and the stop bit is always 1. Okay, so 0 had to be inserted at the start of D0. So the 0 indicates start. Okay, the bit is started from this 0. When the 0 is received at the receiver side, the receiver identifies that some bits are receiving and we have to start the decoding. Okay, so the start bit is always indicated by 0 and the stop bit is always indicated by 1. So stop bit is high, logic high or 1. Okay, so stop bit may be 1 or 2, already I have told. Here you can see a ASCII character. Let us take an example how to represent a ASCII character. So ASCII character A, already told how to represent the A. So here you can see double quotation and its equivalent in a binary form. Here you can see 0 1 0 0 0 0 0 1, the equivalent of A. If you want to send a character A from the sender to receiver, how to make a frame? This is called as a frame. This is called as a frame. So here you can see start bit. This is the received at the first by the transmitter. Sorry, at the receiver. At the receiver, the start bit receives first. While in a transmitting the data through the wire in serial communication, the first bit which is sent out is a start bit. Here you can observe this is the 0 or low. This is the 0. Okay, so this is the 0, then D0, 0 here. This is the 1. Okay, this 1 is indicated by the high pulse. High. Then all are 0. This is the 0, 0, 0, 0, 0. Then again here we have the 1 at the D6 bit. 1. Then D7 you can see 0. At the end of the D7 we have to insert the stop bit. Okay, so stop bit is indicated by high pulse or 1. So this is the stop bit. So this goes last. Okay, this is the first, this is the last. And after D7 we are inserting the stop bit, which is a high. Okay, here you can see the high bit. Okay, which is a high logic or 1. Then we have the space. So this is the space which is used to give some space or time. Okay, so the transmission begins with the start bit followed by the D0, and that is nothing but LSB. This is nothing but LSB, and this is nothing but the MSB. This is nothing but the D7 is nothing but the MSB. When there is no transfer, the signal is high here. Okay, if the data is present, then it is indicated by 0, means there is a data present, and this is the data. This is called the framing. This example is called frame. If there is no data present in the communication, then it is indicated by high. So continuously we are getting high. Like this, continuously we are getting high if there is no data present to be transferred. Okay, so that is called as a mark. Here you can see the mark. Okay, so this is called as a frame. Okay, we have taken an example of a ASCII character A. So A is nothing but hexadecimal is how much? 41. Okay, this is the 441H. Okay, already we explained the number different data types. So different data types are ASCII. Okay, this is one of the example called ASCII character A. So that we have shown here. So this is the example of how the frames are formed. In modern PCs, the use of one stop bit is standard in modern PCs. Now, present day we are using the this type of stop bit. So, in some system, in order to maintain data integrity, the parity bit, okay, parity bit of the character byte is included in the data frame. Okay, so this is called as a parity bit. One more, okay, in some system, to get the maintain the integrity, okay, data integrity. The data should not be corrupted. Okay, the data, what the data we're sending from the sender to the receiver, it may travel thousands together kilometer, or devices are apart of 1,000 kilometer. Even though the data integrity, data should not be corrupted. To maintain the data integrity, one parity bit, one of the method called as a parity bit is also used. So here you can see the whole here from the start bit to stop bit, it will make a total 10 bit data. Okay, instead of 8 bit, D0 to D7 is a 8 bit. Because of this framing, we are getting the 10 bit of data. So UART allows the programming of the parity bit for odd and even and no parity. So already I explained, universal asynchronous receiver transmitter is one of the integrated circuit which are used to implement the serial communication. There we have a programming. We can program this IC chip for these parities. So we have the odd parity, okay, and even parity and no parity options. So these options we can use by programming the UART IC. One more consideration of the serial communication is called as a baud rate. So the baud rate is nothing but number of bits sent per second. Okay, the data transfer rate, it is also called as a data transfer rate. Data transfer rate. So the how much bits is able to send per second. Okay, so that is denoted given by a parameter called as a bits per second, BPS. Okay, BPS, bits per second. And another widely used terminology is called the baud rate. Okay, another is called the baud rate. There are two standards. One is the BPS, bits per second. You might have heard the BPS, kilobits per second. This is the data rate to measure the data transfer rate. And another one is called as a baud rate. So baud rate is used, both are same. The meaning of the BPS and baud rate are same. It is modern terminology. Already told, for the long distance communication, for the serial communication, we have to modulate and demodulate. A device is required called the modem. So this modem is nothing but the modulator and demodulator, which is used to convert the byte into the 0 and 1s, the data into the 0 and 1s. This is performed by the modem, and in modem the data rate is measured in terms of baud rate. Okay, remember baud rate is used in a modem terminology. So the number of signals changes per second. In the modem, it is defined as the number of signal changes per second. Okay, number of signal changes per second. So that is measured by baud rate. In modems, there are, when a signal changes, transfer several bits of data. As far as conductor wire is concerned, the baud rate and BPS are same. As I told, for the conductor, if you consider a wire connected between the sender and receiver, in that case, the baud rate and the BPS both are same. But the baud rate for the modem is signal changes per second. It is a signal changes per second. Okay, so data transfer rate are given computer system depends on the communication ports incorporated into the system. Okay, we have the different ports for the communication. So here asynchronous data transfer baud rate is limited to 100 kilobits per second. Okay, a Pentium based PCs, Pentium series PCs, they can transfer as a 56 kilobits per second. IBM computable IBM PCs, they can transfer from 100 to 9600 bps. Okay, for the IBM PCs, the baud rate is 100 to 9600 bps. Pentium, they can transfer 56 kilo bps. Asynchronous serial communication, they can transfer the baud rate of nearly 100 kilo bps. So these are the different examples of the peripherals. Okay, now let us discuss one of the dedicated IC to implement the serial communication, that is called as a RS232. RS232. So here in RS232 standards, we have a dedicated IC called as a RS232 called as a, here you can see. Okay, so let us discuss the RS232. This is a very important standard to implement the serial communication. The interfacing standard, if you want to connect a peripheral to a device and we want to implement the serial communication, then we have to employ the standard interfacing standard called the RS232. Was set up by the Electronics Industries Association EIA in 1960. Okay, in 1960 they have developed a standard called as the RS232 to implement the serial communication. Okay, and it is developed by EIA in 1960. Okay, so these are called as the RS232. The standard was set long before the advent of the TTL logic family. 1960s only they have developed this standard, but the present day systems, you can say the 8051 microcontroller, what we are discussing. In the microcontroller, it is made up of TTL logic family. Okay, it is input output voltage levels are not TTL compatible. A very important point here is the standard is developed long before the advent of TTL logic. The present microcontroller 8051, they employ TTL logic. Please remember TTL, transistor logic, to fabricate the 8051 integrated IC. And the standard is RS232. Okay, these are not compatible with each other. Okay, here you can see in RS232, A1 is represented by -3 to -25 volts. Okay, -3 volts to -25 volts. A1 is represented. Are you getting? A in RS232, A1, if 1 is received, then the 1 is converted by -3 volts to -25 volts. -3 volts to -25 volts, these are the voltages generated in RS232. If you get 1, okay, you are getting the 1 and zeros from the microcontroller. If you get the 1, the RS232 convert the 1 into the its equivalent voltages, and the voltage level is from -3 volts. Okay, minus 3 volts to minus 25 volts. If 0 is generated, here you can see a 0 is generated, then the zero's equivalent voltage is plus 3 volts to plus 25 volts. Okay, so minus 3 to minus 25 volts is the voltage generated for a 1, plus 3 volts to plus 25 volts are voltage generated to represent 0 by the RS232. Okay, so this is a very important parameter, a very important concept here. So this you have to remember. Okay, 1 is getting from TTL, so this 1 is converted into these voltages. If 0 is getting, then plus 3 to plus 25. Okay, so this you have to remember, very important concept. So here we have a dedicated IC called the MAX 232. The IC is called as a MAX 232. So that is given by the, this is a 25 pin IC. Just remember, it is a 25 pin IC. It is a IC is name of the IC is the MAX 232 and DB. Okay, so this is a 25 pin IC. This is the old one, 1960. It is developed. It was developed. Since not all pins are used in PC cables, IBM introduced the more simplified, instead of 25 pins, only we are now present day we are using DB9. You might have seen this type of connection, the keyboard connected to the PC. Okay, you might have seen the connection of the keyboard to the computer's port. So that is here you can see this like this. This is the figure. So this type, this is the DB9. So instead of the 25 pins, we are using the 9 pins, only 9 pins. This is the advance to the DB25. So DB25 means we are using 25 pins. So not all the pins are used. So instead of the 25 pins, the present day Max IC uses DB9, only 9 pins. So these are the 9 pins: data carrier, detect, DCD, receive data. We can control by this DB9 connector. We can control the different features of the serial communication. Different features of the serial communication. So these are the some of the pin numbers: data carrier, detect, received data, RxD, transmitted data, TXD, data terminal ready. It will use to check whether the data terminal ready or not ready. If the data terminal is busy, then it will generate the wait signal. Signal ground, data set ready, request to send, clear to send, then ring indicator. If the data is received, we have to indicate by raising the ring indicator. That is RI. Okay, so these are the 9 pins of the DB9. So this is the very important block. We are using only the 2 pins called the data terminal equipment, data communication equipment. So this is called the data terminal equipment. Okay, DTE. This is called a null model connection. This is called a null modem. This is called a null modem connection. We have the DTE and DTE. You can see this is the DTE called the data terminal equipment. This is the data terminal equipment and data communication equipment. So data communication equipment is example called the modem. Okay, and data communication equipment. So this equipment is nothing but the modem. Okay, and DTE are the 2 computers. Here we have the computer, here we have the computer, and that will be indicated by DTE, data terminal equipment. This is a data terminal equipment. This connection, here you can see TXD transfer connected to the receiver, and the TXD of the next another DTE connected to the receiver, RxD. TXD connected to the first DTE is TXD connected to the RxD of the next, and the RxD of the first is connected to the next TXD. And here you can see the ground. This type of connection between the PC and a microcontroller requires a minimum 3 pins. Here you can see the simplest figure. This simplest figure is called a null modem connection. Null modem connection. So where we are using only two pieces. Here you can see let us assume this is the from a computer. This is the microcontroller, and we want the communication between the computer and the microcontroller. Only three pins are required: PXD, RHD, and ground. Okay, so this is the PC, and this is the microcontroller, and the use of the three pins, only three pins: PXD, RHD, and ground. This is called as a null model connection. This is the simplest connection between the PC and microcontroller. Already I explained about these. So in next class, let us discuss in more about the MAX 232 chip already told. So this is the dedicated IC. This is called the linear driver. Line driver. Okay, this is used to convert the RS232 voltages to the TTL level and vice versa. Okay, so the connection between a computer and a microcontroller, in between we have to employ this MAX 232, and the use of the MAX 232 is to convert the RS232 levels -3 to -25 to represent the 1, and +3 to +25 to represent the 0. Okay, so these are the voltages -3 to -25 and +3 to +25. These are the voltages generated in RS232, and the TTL levels are 1 and 0s. Okay, so these two have to be computable. To make these two computable, RS232 and TTL levels, we require this MAX 232. Okay, so here this is the shown here. Here you can see voltage. This is also called as a line driver. The name of the IC is called the line driver or voltage converter or voltage converter. There are two names: line converter or voltage converter, because it is converting the voltages from one form to another form. First form is the RS232, and it will convert into TTL format, or for TTL format to RS232 format or voltage levels, vice versa. Okay, so MAX 232 IC. Here this is called the MAX 232 IC, and this is the connection. Here you can see 8051 microcontroller connected to the serial communication DB9. DB9 is nothing but a serial communication. This is the microcontroller. This is the TTL. Okay, this is the TTL. This is the RS232. Okay, in between these we have the different voltage levels. 8051 is the TTL voltage levels 1 and 0 are high and low, whereas here we have the -3 to -25 and +3 to +25. Already explained about the DB9. Okay, so this is the vice versa. To make it a voltage conversion between these two, we require the voltage converter, and that is performed by this MAX 232. Okay, so here you can see this is the IC MAX 232. Okay, here you can see the P out, P in. This is the RS232 side. This is the TTL side. The microcontroller had to connect it to this side, means here 11 and 10, and the 14, 13, 7, 8. These are the pins had to connect it between the serial communication side, RS232 side. So this is the RS232. This is the TTL microcontroller. Okay, so microcontroller is the example of a TTL. Okay, so 9, 10, 11, 12 had to connect it to the this. Here you can see. Okay, 11 and 10. Here you can see the 11 and 10 connection. And here you can see 14 and 13. 14 and 13. This is the 14 pin. This is 13 pin of the MAX 232. So 14 and 13 is used to connect to the RS232. 11 and 10. Okay, here you can see 11 and 10 is used to connect to the microcontroller 8051. This is the TTL logic. We required 4 capacitors: C1, C2, C3, and C4, and connected to the VC and to the 16 pin. Okay, so this is called as a 16 pin is connected to the VCC, and 15 pin is connected to the ground. Okay, so this is the TTL side, this is the RS23 side, this is the MAX 232 IC, and this is the connection between the microcontroller to the RS microcontroller to the serial communication called the RS232 standard by use of the MAX 232 IC. Okay, so let us stop here and discuss in the next class the more about the one more MAX IC card as a 233. Only difference is here you can see there are no capacitors. Okay, so need of capacitor. All the capacitors are removed here. They are shorted 10 and 16, 11 and 5, 11 and 15 are shorted, 12 and 17 are shorted. Okay, the same IC is there, but the capacitors are removed. So this is the advanced MAX 233. Okay, here you can see 11 and 10, 504, again MAX 233. This is the RS232, RS232, and here we have the TTL microcontroller 8051. So remember the MAX 233 and MAX 232. Okay, and MAX 233 is developed from the a company name called the Maxim. Okay, so let us stop here. We discussed today the serial communication and the different types of serial communications, the different data transfer, how to transfer the data, what is simplex, half duplex, full duplex, asynchronous data transfer, synchronous data transfer, then baud rate and what is BPS, and then we discuss about the what is RS232 standard and how we can implement the RS232 standard with the TTL, the MAX 232 IC, which is used to convert the voltage levels between these two standards. Okay, thank you.